Hello everyone, so in this video I'm going to discuss January 31st shift 1 of JEE Mains 2024. So as of now I have received around 17 questions from my students, and first we'll see the chapter wise breakup and then we'll discuss the questions. So in units and errors, so in units there is a question, there is one question, and from the error analysis there is one question. In kinematics there is a question from non-uniform acceleration. And in Newton laws of motion, there is a question of like when a block on an inclined plane it is moving, then what is the acceleration based on that concept, right? Newton's second law. And in momentum, there is a question where conservation of linear momentum. In collision, there is one question which based on the coefficient of restitution. In gravitation, there is a question from universal law of gravitation. In fluids, there is a question from terminal velocity. In simple harmonic motion, there is a question from the relation between the speed and the position of the particle. And in Cartesian thermodynamics, there is a question from indicator diagram. And in electrostatics, there is a question from electric field. And in capacitor, there is a question from dielectric. In current, there is a question where we have to find the equivalent resistance of a circuit. In magnetism, when a current carrying conductor placed in a magnetic field, then what is the force? In ray optics, there is a question from prism. In nuclear, there is a question from mass energy equivalence. And in semiconductor, there is a question from logic gates. Now let us discuss in this particular order. Now the first question is from units. So where f is given as ax square plus b t raised to power 1 by 2 by 2, and we have to find the dimension of b square by a. So here we have to use homogeneity, right? So principle of homogeneity of an equation. So here we have force. So the dimension of ax square should be same as the force. Similarly, the dimension of bt raised to power 1 by 2 by 2 will be same as the force. So dimension of f will be same as dimension of ax square, where x is nothing but the distance. Force can be written as m raised to power 1, l raised to power 1, t raised to power minus 2, and divided by l square, we will get the dimension of a. So from here, I can say m raised to power 1, l raised to power minus 1, t raised to power minus 2 will be the dimension of A. Similarly, B t raised to power 1 by 2 divided by 2, this is having the dimension of force again. So the m raised to power 1, l raised to power 1, t raised to power minus 2. So here 2 is dimensionless. So B dimension of B will be this divided by t raised to power 1 by 2, where t is the time. Now from here, m raised to power 1, l raised to power 1, t raised to power minus 2 minus 1 by 2 is the dimension of B. So if I take the square of B, we will get m square, l square, t raised to power, this will be minus 5, right? And if I divide these to b square by a, its dimension will m square, l square, t raised to power minus 5 divided by m raised to power 1, l raised to power minus 1, t raised to power minus 2. And this will be m raised to power 1, l raised to power 3, t raised to power minus 3. So that should be the answer of this question. Standard question. Now let us see another question, and this question comes from like it is from the error analysis. So if the percentage error in measuring length and diameter of a wire is 0.1% each, then the percentage error of the resistance of the wire. So we know the formula of resistance, it is rho L by A, where rho is the resistivity, L is the length, A is the area of cross section. And area of cross section can be written in terms of the diameter, so it will be pi d square by 4. So, and resistivity, I'm assuming here that there is no error in the measurement of resistivity. So can you see, we have the power of A is 1. Sorry, it is L, not A. So here we have L. So this is L. So the power of L is 1 and the power of D is 2. So we can say the relative error in resistance will be equals to delta L by L plus 2 times delta D by D. And since the relative error in length and the diameter is same, so we can say it is 3 times delta L by L. So if I multiply this with 100, we will get the percentage error. So 3 times 0.1, so it will be 0.3%. So this is the answer, right? 0.3% is the answer. Again, standard problem. Now this question is from kinematics and it is for non-uniform acceleration. So we have given time as ax square plus bx, and we need to find the acceleration. So what we can do, we can differentiate this. If we differentiate this with respect to time, we'll get 1 equals to a times 2x times velocity plus b times velocity. So from here we can say v is equals to 1 upon 2a x plus b, right? Now if we further differentiate this, we will get 0 is equals to 2 a is constant, so v square plus x times, so capital A I'm taking it as the acceleration, plus b times acceleration. Now from here we can say acceleration will be minus 2av square divided by b plus 2ax, and 2ax plus b is 1 by v, right? So this comes out to be minus 2av cube. So that should be the answer of this question. Again, standard problem. Now this question is from Newton's laws, and we have to find the mass of this block, right? We have to find small m, and we have given the capital M and small m are connected with the string, and the blocks are moving with an acceleration of 2 meters per second square. So capital M is moving down the incline with this acceleration. An angle of inclination is also given to us. So what we can do, so there is a force which is mg sine 53 degree down the incline, and there is a force on small m which is mg sine 37 degree down the incline. So the net pulling force in this case will be mg sine 53 degree minus small mg sine 37 degree, and that should be equals to mass of this system, that will be m plus small m times the acceleration, that is given as 2. Now we can simplify this. So I'm taking g as 10. So sine 53 is 0.8. So this will be 8m minus, and sine 37 is 0.6. So this will be 6 small m equals to 2 times m plus small m. So let us substitute the value of capital M, which is 10. So this will be 80 minus 6m equals to 2 times 10 plus small m. Now we can divide throughout by 2. So this will be 3 and this will be 40. So 40 minus 10 divided by 4 will be small m, right? So this comes out to be 7.5 kilograms. So 7.5 kilogram is the answer. Now this next question is from collision. So a ball dropped from the height h rebounds up to a height h after colliding with the horizontal surface. If the coefficient of restitution for the ball for the collision is 1 by 2, then what is the ratio of h and small h? Okay, so what is happening here? So this is the ground, and there is a ball, and so let us say just before so we have released a ball from a height capital H, and after collision the ball rises to a height small h, right? So what is the velocity just before collision? So this velocity will be root of 2g capital H, and the velocity just after collision will be root of 2g small h. Now the coefficient of restitution is defined as the ratio of the velocity of separation to the velocity of approach. So here the velocity of separation is root 2g small h. So we can say E will be root 2g small h divided by root 2g capital H. If we square both sides, E is 1 by 2, so we'll get 1 by 4 is equals to h by capital H. So capital H by small h will be 4. So 4 is the answer, right? Again, standard problem. An artillery of mass m1. So this question is from momentum conservation. An artillery of mass m1 carries a shell of mass m2. Initially, both are at rest. If artillery fires the shell on smooth ground in the horizontal direction, then the ratio of kinetic energy of the artillery and the shell will be. Okay, right. So let us say this is the artillery which is having the shell, right? Its mass is m2 and mass of the artillery is m1. So after firing the shell, let us say the artillery moves with a velocity v1 in the left direction, and the shell moves with a velocity v2 in the right direction. So by since there is no external force acting on this system in the horizontal direction, so we can conserve linear momentum. So we can say m1 v1 will be equals to m2 v2. So v1 by v2 will be m2 by m1, or we can say v1 square by v2 square will be m2 by m1 square. Now if I multiply both side by m1 and divide both side by m2, right? If I divide numerator by 2 and denominator by 2, so this is nothing but the kinetic energy of artillery and the kinetic energy of the shell. So this comes out to be m2 by m1. So m2 by m1 should be the answer of this question, right? So the next question is from gravitation. So four identical particle of mass m each are at four corner of the square of a square. The gravitational force exerted on one of the mass by the other masses is given by root 2 root 2 plus 1 by 32 times gm square by l square. The distance of sides of the square is, okay, now let us first draw the diagram. So we have given four masses which are placed at the vertices of this square, and let us assume the side is a, right? So if I want to find the force, say this is our mass 1, on this mass there will be a force of attraction. Say this is mass 2, this is mass 3, and this is mass 4. So it will experience the attractive force by mass 2 in the downward direction, that is this force is F, and it will experience the same magnitude of force by the mass 4 in the right direction, and there will be a force along the diagonal by the mass 3. So if I take the resultant of these two perpendicular forces, their resultant will be along the diagonal. So the resultant of these two forces will be what? So F will be g m square by a square. So root 2F will be the resultant of these two forces. So root 2 g m square by a square. Now say this force is F prime. So this F prime will be g m square by root 2a, because root 2 is the distance between the diagonally opposite masses. So now the net force on mass 1 will be root 2 F plus F prime. So this comes out to be root 2 times g m square by a square plus F prime, which is g m square by root 2 a square, right? So okay, right, so let me again check. So we have root 2 F, right, and this will be g m square by, sorry, there is a square in the denominator, right? So this will be g m square by 2a square. Let me correct this. 2a square. So if I multiply and divide by 2, so we will get 2 root 2 plus 1 gm square by 2a square. Now in the given expression, this 32l square is nothing but 2a square. So 32l square is 2a square, and from here a will be 4l. So 4l is the answer. Right. So the next question is from simple harmonic motion. So what we have given, a block is performing simple harmonic motion of amplitude A when it is at 2a by 3 from the mean position. Its velocity is tripled. Find the new amplitude. Okay, let us see. So let us say this is the original simple harmonic motion, and when the particle is at a distance, say 2a by 3. So first let us find what is the velocity, right? So let us say this is velocity is v1. So v1 will be omega root a square minus 2a by 3 square. So I have used this relation, v is equals to omega times root of a square minus x square, where x is the position of the particle from the mean position. So from here v comes out to be what? It will be 4 by 9. So this will be root 5a by 3. So this is v1. Now what we have done, we have tripled the velocity. So this velocity has been tripled. So this v2 is root 5 a omega, 3 times of this, right? Now due to this, the amplitude will increase. So but the angular frequency will not change, right? So that will not change, only the amplitude will change. So we can say v2 will be omega root new amplitude square minus position is 2a by 3 only, right? So v2 is root 5a omega, so equals to omega root, and this will be a prime square minus 4a square by 9. So if I square on both sides, so we have 5a square, and this omega will get cancelled out, right? will be equals to a prime square minus 4a square by 9. So from here a prime square will be 49 by 9a square. So a prime comes out to be 7 by 3a. So 7 by 3a is the answer of this question. Again, I would say this is a standard problem. Now next question is from fluids and it is from terminal velocity. So we have to and graphs are given for speed versus time when a steel ball is dropped in a glycerin from rest. So we know that when we release a steel ball in a viscous fluid, so what would happen? First the speed increases and after some time it will attain a terminal velocity. So it will become zero. It will become constant after certain time. So this can't be possible. This can't be possible. It is not increasing. Like it will keep from this graph. It looks like the velocity keeps on increasing. That is not the case. Can you see here? We are getting some terminal velocity, right? So this is VT. So option A is the right answer, right? So next is from KTG in thermodynamics. So it is basically about the indicator diagram. So we have given two isobaric processes and both the curves passes through the origin. So pressure we can say for these, but the for both the graphs the pressure is constant. So PV is equals to nRTs. So we can say V is equals to nR by P times T. So can you see the slope of VT graph depends upon the pressure. So greater the pressure, smaller the slope. So it means if P1 is less, slope will be more. So if sorry, in this case, this say is theta 1, right? And this angle is theta 2. So we know that M1 is less than M2, right? And we know that the slope is inverse. So slope is inversely related with the pressure. So we can say it will be 1 by P1 will be less than 1 by P2. So we can say P2 will be less than P1. So P1 is greater than P2. So option A is the right answer. Now the next question is from electrostatics and it is from electric field. So there are two charges Q and 3Q are kept on a line separated by a distance R. So we have two charges plus Q and 3Q. They are placed like this and the distance between them is capital R. And we need to find the point where the electric field is zeros, and we know that it has to be some point between these two charges because to have the field zero, both the field should be in the opposite direction. So let us say the field is zero somewhere here. So this distance, let us take it as x, and this is r minus x. Now due to this plus q, the field will be in the right direction. Let me call it as E1, and due to this 3q, the field will be in the left direction. Now this E1 should be equals to E2. So we can say qk by x square should be equals to 3qk by r minus x square. Now we can remove qk on both sides. Now let us take the square root on both sides. So this will become 1 by x equals to root 3 upon r minus x. So r minus x is equals to root 3x. So x will be r upon root 3 plus 1, or we can write this as root 3 minus 1 r by 2. So that should be the answer of this question. Next question is from capacitors. A capacitor is connected with a battery. So we have given a capacitor which is connected with a battery. If the charge on the capacitor has increased by 25%, so let us say the EMF of the battery is V and the capacitance is C. So charge, earlier the charge was CV, right? But it has increased by 25%, so it has become 1.25 CV. By insertion of a dielectric slab of width 2 millimeter, then find the dielectric constant. Distance between the plate is 5 millimeter. Okay, right. So now we have placed a dielectric slab and the width of the dielectric slab is 2 millimeter. And let us assume that the dielectric constant is K. So here the new charge is 1.25 CV, or I can say it is new capacitance times the potential, right? So what is new capacitance? So when we have a capacitor with a slab which is not, and the width of the slab is not the distance between the two plates, in that case we can use this formula. So epsilon naught A divided by the, in this case the thickness of the slab is 2. So 2 divided by the dielectric constant plus the width in which we do not have any dielectric, that is the vacuum. So it will be 3 divided by 1, right? So that is the new capacitance. So this will become epsilon naught A K upon 3K plus 2. So this is epsilon naught A K upon 3K plus 2 times V and 1.25, and this C is nothing but epsilon naught A by 5 times V. So epsilon naught AK by 3K plus 2 times V. So this epsilon naught A and V will get eliminated, and this can be written as, so I can write this as 5 by 4. So this 5 will also get eliminated. So 3K plus 2 will be equals to 4K, and K comes out to be 2, right? So 2 is the answer of this question. Yes, so the next question is from current electricity, and here we have to find the equivalent resistance between A and B. Right, so let us see. Now this 6 ohms resistor is short circuited, so we can remove this. Now this 2 ohm and this 2 ohm are in parallel. If they are in parallel, it becomes 1, right? So these two are in parallel, so it becomes 1 ohms. Now this 1 ohm and this 2 ohm are in series, so becomes 3. Now these two will become 3. Now we have 3 resistors which are 3 ohms each are connected in parallel. So the answer will be 3 by 3. So it will be 1 ohms, right? A very basic question. Now the next question is from magnetism, where we have to find the force experienced by a current carrying conductor in magnetic field. A current carrying wire is placed in external magnetic field. As shown, find the magnetic force on the given wire. So we have to find the magnetic force. So since the magnetic field is uniform, so what we're gonna do, this is the starting point of the current and this is the end point of the current. Let me take it as A and this point as C. So if I join these 2 points like this and assume that the current is I in this particular wire, straight wire. Now what is the force? So it will be I, let us say this length is L cross B. So L is in the right direction, so the direction of L is nothing from the nothing the direction of the current, so it will be downward direction, right? So it will experience force in downward direction, and the magnitude of this force will be I. L in this case will be the diameter of this length, right? Diameter 2r times B, and it will be in the downward direction. So that should be the answer of this question. Now the next question is from ray optics, and it is from prism section. So where we have, again, it is a repeated question. I think it was there also. It was also in I think 28th shift. Find minimum deviation in the thin prism if mu is cot A by 2, where A represents angle of prism. So mu is given as, we know that the formula of mu is A plus sine A plus the minimum deviation divided by 2 divided by sine A by 2. And mu here is given as cos A by 2 divided by sine A by 2. Now this will get eliminated, and we can say sine A plus del minimum by 2 is equals to sine A by 2, and this will be plus pi by 2. Okay, right. Plus pi by 2. Let me just check. Right. So it should be pi minus pi by 2 minus A by 2. Pi by 2 minus A by 2. So if we equate the angles, so we have A plus del minimum by 2 is equals to pi minus A by 2. So 2 will get eliminated, and we will get pi plus minus 2A, right? So option B is the right answer. Now let us see the next question. This question is from nuclei chapter. So if mass defect in a nuclear reaction is 0.4 grams, then find the Q value. Very basic question. It is based on these concepts. The energy released will be mass times C square. Mass is given as 0.4 grams, which is 10 raised per 4.4 times 10 raised per minus 3 kilograms, multiplied with 3 into 10 raised per 8 square. So this will be 9 into 0.4 times 10 raised per 16 minus 3. So it is 3.6 into 10 raised per 13 joules. Now that is the answer of this question. Next is the question from semiconductor, and it is from the section logic gates. So we have to find that this combination, this circuit gives us which type of a gate. Let us see. So we can apply Boolean algebra in this. So here we have a NOT gate. So here we'll get A bar, here we get B bar. Now this is a NAND gate, so it will get A bar times B bar whole bar, and this is by De Morgan's theorem, this is nothing but A plus B, and A plus B is nothing but a OR gate, right? Now you have seen the questions, all questions were doable. So if you have yet to give your exam, so you should be happy about that, because paper is quite easy and you can solve 100% of the paper in the limited amount of time. So all the best for your exam.